So this is an introductory lesson on using the chain rule when finding derivatives involving sine and cosine. We will spend more time on this on Monday, and then we will also look at the derivatives of the other 4 trig functions. So I want to remind you that the chain rule, which we should be experts on by now, says to take the derivative of the outer, keep the inner, multiply it by the derivative of the inner. Okay, and we had that exercise earlier where you were identifying what was inner and outer. So I made this little chart, right? And on the left, I said functions where sine or cosine is the inner. Okay, what do all of these have in common? It's probably not very hard to see, right? That every one of them has a power, it's being raised to a power, and then the angle, because x is representing the angle. There's no such thing as a trig function without an angle, okay? Trig functions are functions which operate on an angle. So these are all functions that the trig function itself is being raised to a power. So what I had suggested the other day was that every time you see, I'll be consistent and write in red here. Every time you see this, I want to suggest that you write this in its equivalent form, which is sine x to the quantity, that quantity cubed. Okay, now this looks just like the chain rule you've been doing all along, except the inner function is the sine function. Okay, so we go to do the chain rule, and we say the derivative is 3, drop the 3 in front, keep the inner, sine x is the inner, decrease the power by 1, so we did the chain rule, or the power rule on this outer shell, and then we do times the derivative of the inner, which is cosine. Okay, I am okay if you leave your answer like that with the sine x in parentheses squared. If you rewrite it, make sure that the squared goes after the n, not after the x. Okay, so if you rewrite it, the proper way to rewrite it is like that. Okay, I give full credit to the answer above, but if as you mature as a mathematician, you would give this answer. That is how we typically write when we want to square or cube or whatever power for a trig function. So let's look at cosine. Okay, and same idea. Okay, this is in parentheses, cosine x to the 5th. Okay, so to find the derivative, we do the derivative of the outer shell, 5 cosine x to the 4th. I'm going to put it in parentheses if I can squeeze that in, cosine x to the 4th times negative sine. Sometimes students go like this, and that does not say times negative sine. That says take that expression and subtract sine, right? That's how that reads, okay? So put it in parentheses, but as I've been saying all along, negative signs, they're part of our coefficients, which belong out in front, okay? So I suppose I'd give this answer full credit, but I really prefer you to take that negative, bring it out in front, okay, and then have cosine, put the 4 after the s, cosine to the 4th x times sine x. Okay, but as long as you have parentheses here, I do give that full credit, okay, but I'd prefer that negative sign to come in front. So for participation, do this and send it to me. Okay, let's look over on the other side then. What happens when the angle is the inner function, okay? If my angle is anything other than x or theta, then the angle is the inner function. So what we have to do here is take the derivative of the outer, right? So that makes sine the outer. This is the outer. Take the derivative of the outer, but keep the inner. Okay, so derivative of sine is cosine. Keep the exact same angle. Then times the derivative of the inner. Okay, inner is the angle. What's the derivative of 3x? It's 3, right? Because this is my, I'm going to call that my, I'll label that I, and this is my O, inner and outer. What we don't like is when you put the 3 back here. Now that's confusing. Am I multiplying the 3x by the 3 or what are we doing? Okay, so for this one, I am not going to give this answer full credit. Okay, coefficients belong in front. So you'd want to write this. Okay, so compare this back to the original. Okay, I took the derivative of sine, I got cosine. Kept the angle the same, times the derivative of the angle. All right, so let's try this next one together. Okay, so again, angle is the inner. Here's another common mistake is students think this means product rule, right? They look at this and say, oh, well, isn't there a time sign in between here, right? No, there's not, because this is the angle. If I wanted to have you use the product rule and multiply x squared times cosine, first of all, the x would go in front of the cosine because that's the proper way to write it. And then the cosine would have to have an angle, right? So I'll just make the angle x. Okay, so this is saying x squared times cosine of x. This is not saying cosine times x squared. Okay, this is cosine where the angle is x squared. Also important to note, this is not equal to this. Okay, here is where cosine is the inner and the squaring function is the outer. Okay, here cosine is the outer and the inner is the angle. Okay, so I want to take the derivative of cosine, which is negative sine. Okay, negative sine, keep the angle exactly the same. Okay, so keep the angle, the x squared, times the derivative of the angle. So again, you're probably tempted to write 2x back here. Okay, we don't like that. It's too confusing, right? Do I want to multiply x squared by the 2x? Is this part of the angle? Is it a different function? That's what gets confusing here. So we want this to come right into the front. The negative should be the first thing we write. Then we write the 2x. So I just always leave space in the front of my trig functions. All right, I just leave the space there because I know instead of putting my derivative of the angle last, I want it to come out in front. Okay, so for example, if I'm doing this in letter y, and actually, even though this is more complicated, I still get the same derivative, right? Derivative of sine is cosine, okay? So I leave a little space here. I'd have cosine, keep the exact same angle, x squared plus 7, right? But I left space in front, sorry, that's x squared plus 7, to take the derivative of the angle, which is 2x. Okay, so along with doing the derivative of sine to the 10th x, also send me the derivative of this, and that'll give you participation credit for today.